Good evening.
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 Hey guys, how are you doing? Hey though. Hello? Oh, hello guys.
Hi, sir.
How are
Hey,
you?
evening, sir.
I'm there talking to you and not remembering that I had muted the stuff. Oh, this is where it's at. All right, how are you?
Not bad.
I saw your stuff, Mikey. Just that we had open day today and they laid hands on me to do things that I didn't prepare for. And hold on. Hold on a minute, please. All right. So when I look at those stuff, those stuff will be easy fixes, Mikey. You don't have to worry about those. But yeah, today we had open day and it kind of just took out a chunk out of a big chunk out of my day. Um, but I'm happy that I'm here. We are going to be having, as I told you, we're moving on to something new. I'm a little concerned that the just half of the class has been really coming out consistently. So now half of the class understand what is happening, and I'm wondering about the other half of the class if the understanding is there. But let us see what will happen. We're onto some probabilities, but before I move into the probabilities now, let me ask you, sorry, let me ask you, um, what things, are you okay? Are you feeling like this course is making sense? Like you think you can pass the course? Um, what say you? What are your thoughts? How is it going so far?
For me, it's good.
Nice.
Yeah, understanding, and it's actually good to apply to day-to-day work. So it's good. It's
Yes.
good for me.
Yes. Yes. And yes, I would agree with you. I think you are understanding. Anybody else?
For me,
Uh-huh.
throughout the class, I realized like with some of the examples you've used, I see where it can become applicable.
Mhm.
For me personally, I think for this semester, I think this is one of the best courses I'm doing so far that I can really get a grasp of.
Okay. That's
Yeah.
that comment is very welcoming. Thank you. Thank you. All right. Yeah. So I'm trying to show you all the ways you can use the statistics. One of the comments has sorry, from the first batch of this is the second iteration of the environmental stats. And in the first iteration, one of the guys, matter of fact, the only male who completed the course, um, he will tell you he dislikes math. I taught him pre-calculus in the associate, and he did well. I mean, he picked up a B, but he just math is not his forte. And he passed, well, they all passed the environmental stats the first time around. And he touched base with me and said to me, he got a promotion at work and was required to do some reports, collected some data, and he had to go in front of the big wigs to report. And he said to me, say, yo, you want to see me and use the statistics? You want to see me and use the statistics? And God did know, say, when did I teach them topic in our class and they need not paying attention, but you want to see me go back for the notes them and do the stuff, and it was well received. And things like these, make me feel good because at least you not only learned, but well, in his case, but you are able to put into practice. Um, sorry, the things that are going to be necessary for growth and for the place of work. People supposed to recognize a blow, so since a man did degree, him a work differently, you can't make a man say to you, say, him get degree and I mean asking a difference in the way the man do. No, man. You have to see a little difference in what is happening. All right. Anybody else before we jump into it? All right. I don't know why to start talking now, but anyhow. Um, so we need to have a conversation. Today we're going to be looking at some probabilities. And I know this is not bad. This part of it is also very nice. Um this part of it is also nice. I remember doing this with um, you know, a young family member around when I was teaching the environmental studies, the BSc students, and I was teaching them this stuff. And one day I was just having a quiet moment, and out of the mouth I'd hear boy, girl, boy. And I was like, what the heck? I said, where did you get that from? Oh, I was listening to you teach in your class. I was like, oh my goodness. So if a toddler can get this, um, I'm sure you two big grown people will be able to get it. All right. So enough of that. Let's go. We are going to be having a conversation now on some probabilities. And the conversation that I want to have, yes, I will write, but for now, I want to talk about two things. Sample space and an event. Sample space and an event. What is a sample space? Or what is an event? So a sample space of a statistical experiment is going to be the set of all possible outcomes. That is a sample space. Every possible outcome that can exist. You not hear me?
No, I'm hearing it. Are you sharing your screen or are you just
Oh
talking?
no, I just talking now. I just talking now because I don't know why I'm talking, I'm talking now because what I'm going to be doing a little later on, I didn't even recognize that you're in class, Done. I'm talking now because my next thing is to write, and uh, But which is where's that thing? The next thing that I'm going to do is to write. So I'm just talking now. So a sample space is of a statistical experiment is a set of all possible outcomes. All possible outcomes. Say, for example, I'm going to be flipping a coin. If I flip a coin, what would be the possible outcomes of flipping a coin? Hold on a minute, please. Hold on 1 second. Hold on 1 second. 1 second. Right. So I was saying to you, if I were to flip a coin, what would be the possible outcomes of flipping a coin? What are the possibilities of me flipping a coin?
Getting heads or tails.
Very good. So what is the sample space of the experiment?
Head or tails?
Very good. Remember, I said to you, the sample space of a statistical experiment is the set of all possible outcomes. It is going to be the set of all possible outcomes. Now, I need to look at the outcomes. What is the outcome of flipping a coin? Either I'm going to get a head or I'm going to get a tail. But, sir, what if you split the coin as many times as is necessary, and every time you flip the coin, you get a head? Not a problem. The sample space is still a head or a tail because the possibility is me getting a head or me getting a tail. So remember, so if I flip a coin with two possible outcomes, head or tail, it means that my sample size, my sample space of that experiment is going to be either a head or a tail. Follow me?
Yes, sir.
Yes, sir, so far.
There's going to be a flip question to that. And that's why I know that's why I took out the writing device. I'm not going to ask you that just yet because I want to talk to you about an event. What do you think an event is? An event is going to be a subset of the sample space. Now, hear me out. Me flipping a coin and getting a head every time, that is going to be my event. My event is a subset of the sample space. My event is what occurs when I do this experiment. Does that make sense?
Yes, sir.
All right. So I'm going to come back to this example, but I am going to give you an example. Say Asia met the guy of her life. They got married and she's going to give birth. What is my sample space of her giving birth? Either a
boy or girl.
But what would be her event? Either
her getting a boy or her getting a girl.
Or she getting a girl. Good. Excellent. And then her event could also be getting 2 girls or 2 boys. In the event that, for that single pregnancy. Or guess what?
Or 3 girls and 3 boys.
Or she may get 2 boys and 3 boys. And I don't think in our region we have 4 children. I mean, quadruple children, right? I can't recall in within our region, but I know in Jamaica we have triplets.
All our high has I think number of 4
I don't
quadruplets.
I don't know, but I know you can have septuplets. I mean, I've seen in the newscasts of people giving birth to 7 children. Oh my goodness gracious. What a catastrophe. 7 of them one time? No man. If I have 7 of them one time, I just get called one, two, three. The first name is going to be one. The second name is two. One Shand, two Shand, three Shand. Because I know I'm going to get mixed up calling their names. But remember now, the sample space is going to be the possibility of all my outcomes. You know why I'm sticking on that? Because oftentimes for the multiple choice, they ask you which of the following defines a sample space, and then give you A, B, C, and D. And you read it, you're supposed to recognize that the sample space of a statistical experiment is going to represent the set of all possible outcomes. You can also call it the sample point, right? My event is going to be a subset of my sample space. My event is a subset of my sample space. My event is what happened when I would have conducted an experiment. But the sample space is going to be the possibility of all outcomes. All right? I want to know that you guys get what I'm talking about. Please just let me know
Sorry,
that you.
excuse me. So in the case of independent and dependent variable, the independent variable would be the space, and the dependent variable would be the event.
No. What would you call a dependent variable though?
The event. The event.
The event?
Yeah.
No, because you won't have an independent event taking place in this case, because yeah, it will still be an event. It will still be an event, because remember, your events cannot be outside of cannot be more than your sample. You follow what I'm saying? Your event, any amount of event that you get cannot surpass your sample space. I don't know if that makes any sense. You know, like I said to you when we were doing I didn't say to you then. Yes, when we did the probability distribution, the sum of all probabilities equals to 1.
Yes, sir.
Yes, sir.
Can't pass 1. So any event at all that you're doing, in as much as how you perform the event as many times, a gazillion times, you cannot surpass the sample space, because the sample space tells me what it is that it's going to be. So if I have a class of 6 students, 3 for year 1 and 3 for year 2, it means that my sample space is going to be 6. I don't have more than 6 students. What is the event coming out of the attendance for class regularly? It's either 3 or 4 students. But I cannot have 7 students turning up for class.
Yeah, I understand what you're saying, sir.
Right. Because what the heck? Why am I coughing? I cannot have 7 students coming out of class, because if there are 7 students in class, I'm going to ask, who are you? Because my sample space is 6. All right? All right, very good. Am I sharing? No, I'm not. Let me share something with you, because I want to be able to have that level of conversation that will take it to a different level. And when I say different level, meaning that you are understanding what is happening. Okay, so if I flip a coin, my sample space is either going to be a head or a tail. If I flip a coin, I am going to get a head or I'm going to get a tail. I'm going to get a head or I'm going to get a tail. So my sample space here is going to be 2. My sample space is going to be 2. What if, and I want you to think about this, what if in another experiment, I am flipping 3 coins. I'm flipping a coin 3 times. Guess what it's going to be? I'm flipping a coin 3 times. Tell me what, guess what it's going to be?
You're flipping one coin 3 times.
Yeah.
I think it's still 2 because the sample space is either head or tail.
Sorry, say it again. Mikey.
Oh, I was saying that I believe that it's 2 because the sample space will still be head or tail because it's the same kind of flipping repeatedly.
Yeah, man. But remember, no, I am flipping the coin. So if in every experiment, for the experiment, I'm flipping the coin, that single coin 3 times. So I'm flipping a coin 3 times. So for that, what's happening? For that second experiment, I'm flipping a coin 3 times. So let me ask you, if I flip a coin 3 times, what are the possibilities? So it's the same coin that I'm flipping 3 times, and I get 3 chances. You know, when you play one game and you get 3 chances, I get 3 chances to flip a coin. When I flip the coin the first time, what could I possibly get?
Head or tail.
The head or tail.
No.
No?
When I'm saying when I flip the coin, the first time, what do I get? I can't get a head or a tail. I have to get one or the other.
Oh, so you can put
Is what I'm saying?
yeah,
So hear me out. So when I flip the coin, I can get a head the first time, I can get another head, and I can get another head. When I flip the coin, and this is one experiment. In one experiment, I flip the coin, I can get a head, and a head. And it's a blow. Oh, you're getting 3 heads. But in another experiment, I can get a head, and I can get a tail. But in another experiment, I could get a head, I could get a tail, and I could get a head. But in another experiment, I could get a tail first, then a head after, then another head after. Right? Hold on there.
the report about 6.
You said 6. All right, that's a very good attempt. You said 6. Let us see if it is really 6. So
The next would be tail, head, tail, and then
okay, I like your
tail,
thinking.
tail.
Hold on. Take time. Take time in my man. Come on, me for right. The next event is going to be what?
Tail, head, tail.
A tail, a head, and a tail. Okay, is there any other event?
Tail,
Tail, head.
A tail,
Triple
a
tail.
tail, and a head.
No, tail, triple tail.
Triple tail.
triple
You
tail.
can get that too. Mhm.
Okay, what else? Is there anything else?
Also, you have 1-2 time, you know.
We shouldn't have
But the
two.
head,
Hold
tail,
on.
head, and then
Oh, oh no, Buddha said 2 time because it's the order in which when you flip it,
yeah,
Uh-huh.
write it
hmm
down.
yeah.
So the possibility is
Yeah, go ahead.
the
Is there,
possibility could be endless.
you sure? But I need to know what my sample space is. So you tell me no. You tell me no. Will that represent my sample space? Could I get a head, a head, a head, a head, a head, a tail, a head, a tail, a head, a tail, a head, a head? Then he's saying that I could get a tail.
Sir, head, tail, tail.
Say it again.
Head, tails, tails.
Head, tail, tail. A head, a tail, and a tail. Is that correct?
Yeah.
So how many do I have there?
8 so far.
8.
8 so far.
Mm.
And 8 so far is going to be 8. No, you said something, Mikey, and I want to go back to that. I heard you. I ignored you because I didn't want to talk about it yet. You said to me, but I have it already. And then you said something. What did you say again?
Different order.
The order in
Does
which
it matter?
Yeah, the order in
It does.
which.
It does. Because a head, and a tail is going to be different, is a different outcome than a head, a tail, a head. You follow what I'm saying? Put it this way. Put it this way. You may have a boy and a girl, but that child or those children will tell you, I am the firstborn. Matter of fact, scrap that. I love talking to twins. Because guess what? One of them is going to tell you that I am older. I was like, but you're born the same day? No. I'm 5 seconds older, or I'm 10 seconds older, or whatever the situation. The one who came out first will proudly say to you that I am the older of the two. Anybody ever hear that conversation before?
Yep.
Yeah, man. And guess what? The older sibling is going to rub it in the face to say, I'm older. And then somebody going to say, but the two on the 1st of January. I don't care. Me come out first. I say, yeah, man. You want thug. You want bully. Because your other sibling chances are the one come out first and just push them out of the way and decide, say, no, you come out first. So you're a bully. But I'm saying to you, order is important. The order is important. So watch me. Watch me. Yes, I agree with you that a head, and a tail occurring could be the same thing as a tail, a head, and a head. But this tail occurred last. But this one occurred first. So order.
Sorry, what about the HTH? The one in between.
Even that too. This one going to say that I came second. I'm the sandwiched one. I'm the Oreo. All right. So and if you look at it now, this one could also say, right, only those three with 2 heads. Right? So I can ask you now, here I can twist up the question because I really want to get this tonight. Here I can twist up the question. As Didi asks about, what about the one in the middle, sir? I can say to you, a coin, a single coin, is flipped 3 times. What is the probability of getting 2 heads?
2 times.
Three times.
What 3 times?
Yeah. Two heads here, two heads in the middle, two heads on the other side.
I can get a head, I can get a head and a tail. I can
Mhm.
get a head, a tail, and a head.
Yep, yeah,
And
and
I
a
can get a
tail
tail, a head,
and
and
a
a
head.
head on.
Yep.
So the probability is going to be 3 out of what is the sample size?
What, 3?
8. 0 to 8.
3 out of 8.
Oh, 8, yeah.
So the probability of me getting 2 heads, flipping a coin 3 times is going to be 3 out of 8. 3 eighths. Let me ask you, what is the probability of me getting 3 heads?
1
1 over
out of
8.
8.
Very good. Excellent. What is the probability of me getting 3 tails?
1
1
over
out of 8.
8.
Very good. What is the probability of me getting 2 heads? Sorry. Yeah. What is the probability of me getting 2 heads first?
1 over
1 out of 8.
1 over 8. Yeah,
You
2 heads
sure?
first.
2
Yeah,
out of
2.
2
8,
heads
sir?
first. Huh?
No, would that be no 4? No
Is
4?
it 2 out of 8?
2 out of 8, yeah. Because remember, I said, what is the probability of getting 2 heads at the first go? So
So
I
it no
can
matter
get,
if a H again come on the third one.
you know, much if I H come on the third one or a tail come. What is important is I get my heads and my heads first. So this one, let me show you. This one gave me 2 heads first. I don't care what come after. And this one gave me 2 heads. I don't care what come after. Says only those 2 gave me 2 heads the first try. Are you getting this?
Yep, yep.
Is there anyone in the class that is not seeing what is happening? Are you getting the gist of it?
Yeah, picking it up, sir.
Yeah, man. So, and then now I can ask you, there are so many questions that I can ask you from this. A whole lot of questions. So just remember, what I want you to do is, I want you to be able to tell me the probabilities of my event. So my sample space here is going to be, my sample space is going to be 8. Sir, how do you know that your sample space is going to be 8? All right, let me show you something here, because all of it is pre-calculus. What is my sample space for flipping a single coin? What is the sample space of flipping a single coin? Very good. Excellent
2.
answer. 2. How many times am I flipping the coin in this case?
Um, 8.
24. 24.
Yeah.
4.
How many times? No, man. How many times am I conducting this experiment?
Roughly 20.
With a single coin?
Yes. How many times? But
So,
how many tries do I have in a single experiment? That's what I'm asking you.
Oh, 3.
Oh,
3 tries. Don't everybody say that?
yeah, yeah,
No, sir.
the set.
1, 2, 3.
oh yeah,
1,
yeah, yeah.
2, 3.
Mm-hmm.
1, 2. Is it that?
Yeah.
So there are three tries I have in a single experiment. Can you agree with me?
Yes, sir.
Yes.
So when I have 2 raised to the third power, what is 2 raised to the third power? It's 2
8.
times
2
2
times.
times 2.
Mhm.
So let us count now. 1, 2,
1,
3,
3,
4, 5, 6, 7,
8.
8. Do I expect a ninth one?
No.
No.
No,
sir.
I can't get a ninth one because I have just worked out my sample space. I've just worked out my sample space. All right. So what you can do, you can try to write your events in order. We never did it in order just now. Let us try it in order now. I can get ahead, ahead,
And
ahead.
ahead.
Good. I
Tail,
can get
tail,
ahead,
tail.
ahead.
No. Oh.
Well, I'm going to use the heads first. So I can
Alright.
get ahead, and then a tail, and then I can get ahead, a tail, and a head, and I could get what now? A tail, a head, and a head. What else?
Tail, head, tail.
Then I could get a tail, a tail, a head. I could get a tail, a head, a tail. Do I have a head, a tail already?
No.
I could get a head, a tail, a tail. What is left?
Triple tail.
Excellent.
Oh, the tail, tail, tail.
Triple tail. Very good. You see how easy it is? When you
So
think
that
about it
I
in sequence.
resemble the Pascal triangle formula.
And you know, to be honest with you, it is just like how Pascal's is done in order. 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1,
Yeah.
1, 6, 20, 15, 6, 1. Yeah, man. Those are they. So everything is done in order. This one here is also in order. But if you go into the exam and you can see it and you can write down the sample space or your sample points, it's not a problem. They just want to make sure that you know what are the possibilities. Tell me that you're following me.
Yeah, following so far.
Good. So let us talk about a little something more. So when I have that experiment and I flip a coin 3 times in a row, three times in a row, remember I can get the different outcomes at different points. Meaning a head, a tail, a head, a tail, a tail, a head. And if I have 2 tails, those occurrences are different from each other because order is important. Order is important. Order is important. Does that make sense? Hello? Is somebody?
Yes, sir.
All right. I'm going to show you something. I'm going to show you something else. And I'm going to introduce it to a probability tree. So I have a coin. And when I flip that coin, I can get either a head or a tail. Agreed?
Yes, sir.
From here, I can get either a head or a tail. Agreed? Talk to me now.
Yes, sir.
And from here, I can get either a head or a tail. So don't.
Yes, sir.
Sorry, I said tail and a right head.
Yep.
From here, I can get either a head or a tail. Talk truth.
Yes, sir.
All right. Here, when I flip that, I can get a head or a tail, don't it?
Mm-hmm.
And here I can get a head or a tail. And here I can also get a head or a tail. Now, what I want you to look at it. That's
Sir,
one event. Yes, please.
to confirm, you're saying that For the first H at the top, when you flip back the coin, the possibility that you can get head or tails, hence the two thing right here.
Right. So the 2 is telling me what my sample size, my sample space is. Only 2 events I can get. And then the 3 is telling me how many times I'm doing the experiment. Follow me?
Yes, sir.
No, I don't think so. Ask the question again.
So you said the 3 would be representing how many times the event takes place, and the 2 is the possibility.
Very good. Very good. Work with me now. I don't want anybody to write. I want you to look at the screen right here. So let us see if I can if I can get it otherwise. Watch me. Watch me. I can get ahead, ahead, ahead. Can you see that?
Yes, sir.
Which is right here. So I can get ahead, ahead, or a tail. You see that?
Yeah.
Or I can get a head, a tail, and a head. Head, a tail, a head. Or I can get a head, a tail, and a tail. A head, a tail, and a tail. So those are the possibilities I can get starting off with the heads. 4 of them. 1 starting off with the heads, 2 starting off with the heads, 3 starting off with the heads, 4 starting off with the head. So I can say to you, what is the probability of me conducting 3 experiments and getting ahead at the first chance? What would be the probability?
4.
4 what?
4/8.
4/8. Very good. And then I can say, and what is the probability of getting, what's the probability of me getting a tail at the start of the experiment?
4/8.
4.
And the sum of the probabilities is going to be equals to
8.
4/8 plus 4/8 equals what?
8/8 equal 1.
1.
Which is equals to 1. Yeah. So the sum of the probabilities is always equal to 1. Can't surpass 1. It's going to be equal to 1. All right? Hold on. I'll come in. Give me half a second, please. Sorry. Who was asking a question now? Somebody was asking a question. Hello? Are you guys hearing?
Yes, sir.
Yes, sir.
Yes, sir, I hear you.
Yeah, I was asking, somebody was asking a question before I muted. Oh, nobody's asking a question? Okay. All right. I thought somebody was asking a question. All right. So look at my probability tree. I use my probability tree in order to help me figure out the the events, the possible events or the sample space of my experiment. Can you see that?
Sir, how do you get the sample space from this diagram?
Watch me.
Like how do you get the A?
All right. All right. Watch me now. You see one?
Yes, sir.
I don't think I have enough colors to demonstrate, but that's 1, 2, three, 4. You see that?
Yes, sir. Seeing it now.
4, then 5, then 6, then 7, then 8. Follow me?
Yes, sir.
All right. Are there any questions so far?
No, sir.
All right. Um, all right. So I'm gonna give you another scenario. So I'm finished with this scenario. This scenario is finished. There's nothing more I can do with this one. This scenario is finished. All right. That scenario is finished. I'm gonna give you another scenario. I'm gonna give you another scenario. Hmm.
Oh, sir, what do the red boxes represent again?
The events,
Oh,
the experiments.
no, yes, sir.
All right. I reach a point in where every time I'm supposed to be adding a page, it give me a problem. All right, I think I just added a page. All right, so I give you a question. I give you a question and I want you to think about it. I want you to think about it, and then we're gonna have a conversation on it. We're gonna have a conversation on it. So I have 2 balls, each containing 100 balls. Each containing 100 balls, numbered 1 through 100. I pick a ball at random from each ball and look at the numbers on them. How many elements are in the sample space for this experiment? Don't answer yet. Don't answer yet.
Sir, before you answer the answer, you know, the first thing that come to my mind when you put that question here.
Lotto.
Exactly.
I know, right? And I don't know if when you heard me read it, I kind of pause. Yes, I know I needed to clear my throat, but I paused and I said, "Oh my goodness, look how good Christian boy. I'm gonna carry a lot to go in class. We could teach, right?" But yes, you're correct. So I'm gonna have it there. I want you to take 2 minutes to read through, think of what the question is asking, and then I'm gonna come and have a conversation on it. Starting now. All right. So you have read the document, the question, and what do you think it's asking? What do you think it's asking? It said, suppose I have two bowls, each containing 100 balls, numbered 1 through 100. It's numbered 1 through 100. I pick a ball at random from each bowl. I pick a ball at random from each bowl and look at the numbers on them. How many elements are in the sample space? Meaning, how many times can I do this experiment? How many elements are in the sample space?
Answer?
Yeah.
I said 200.
100.
Okay. Okay. Who said 100 a while ago?
Me, sir.
Oh, you're in class. Hold on, let me see one more here. Oh, Venica. Oh,
Is that
Jesus.
trying to drive and listen?
Okay, so all right. So I hear 100. I hear 200. Hey, hey, Asia, what you say? I bet Asia gonna eat food again.
No,
Mr.
sir, me there,
Answer.
me a charging of a number.
You so quick to ball out, Mikey? No, sir, no, sir.
Yeah.
Yeah, you so quick to ball out. That's what I should,
Sir,
that's
what's
what I
the
should,
answer?
that's what I should have saw, you know. What's up, BD?
What's the answer?
Me not telling the answer, me not hear nothing from you yet. You're out, Jordan. Tell me what you get first. She swears she's smart to know. What's the
I was
answer?
thinking 100, I don't know.
You're thinking 100 like Benika. All right. Um,
Oh my God. Mute.
mute for me. Mute. Pause. Where you say? Oh, you did answer pause. Mikey, you don't answer yet, you know.
Sorry, give me 10 seconds.
Yeah, I love it.
All right, so sir, if you have 2 balls a ball,
Mm-hmm.
which equals to 100 each, so that's 200 balls. And then
Mm-hmm.
say you pick a ball at random and look at the number and then how many times you could 200 times. Because if you go pick a ball at random, I would say 200.
All right. Let me put the question in another way. What is the total number of possible outcomes I will have?
So you're picking from both bowls at the same time?
Let me see what the scenario says. Suppose I have 2 bowls, each containing 100 balls, numbered 1 through 100. I pick a ball at random from each bowl and
Mm-hmm.
look at the numbers on them. So it is suggesting that I pick a number from each bowl and look at the numbers. It says at the numbers on the, how many elements are in the sample space?
You're saying 100.
200.
Yeah, okay, 100 total. All right, I hear you.
Sir, but I think I understand what they're saying in terms of like why they said 100 balls, but it said each containing. So wouldn't each container be 100?
Yeah, that's how I read it.
So that's how I read it. I
But how
say
much?
each containing.
But I'm thinking about how many times they can pick like one from each.
They pick up one,
To
they
make
pick
it
up
be a
the next one.
pair.
Or the numbers, because you'd have
Because each other
you'd
have
have
two.
2
Like,
1s, 2
yeah.
2s, 2 3s. You know, so many I think it be.
Yeah. Maybe I think about like each one would compensate one because they're 100 each and it balance. The 2 container them equal.
Okay, I hear
So
that. Go ahead.
that makes sense as well. But
Mm-hmm.
I am looking at it from the amount of times you can actually do the experiment, which should have been 200 times.
200. That's how I see it as well.
Okay. All right, so let me ask you a question now. If I flip a coin, a single coin, 3 times in an experiment, what would be my sample space?
8.
How did you get the 8?
Oh, the sample space too, sorry.
No, you're correct.
Yeah. Oh, the
The sample
event.
space, right? The event, no man. The sample space is going to be 8, you know.
Oh, yeah, the subset of the event, yeah.
Right, the sample space. So the event is going to be either is the event is a subset of my sample space. So a head is a subset of the sample space because head is contained in the sample space. A tail is contained in the sample space. A head, a tail, a head. A tail, a head. All of those are my events.
In the
And
sample space.
all of my possible events will end up giving me my sample space. My sample space tells me what it is that I have to work with. I cannot go above that. So whatever I do, that is going to be my sample space. So I'm saying to you, what I'm asking you, again, I have 2 balls, each containing 100 balls, numbered from 1 to 100. I am picking a ball at random from each ball, and I look at the numbers on them, how many elements are in the sample space for this experiment.
2 to the power 200.
But I said about 10,000.
How would you get 10,000, Mikey?
2 to the power.
Yeah. 2 to the power 100.
100 to power 2.
2, yeah, 100 to the power 2.
Asia, why would you say 100 to the power of 2?
Sure, because it's 2 bowls and it doubles the chance, as you can see. So if it's 100 balls in each, then
And I am, don't say then, it's 100 balls in each, and I am picking a ball
one
from
ball.
each
Uh-huh.
in a total of
100 times.
no man. I'm picking I'm picking out 100. There are 100 balls in each, but I'm picking a total of how many balls at a
2
time?
balls.
2 balls at a time. So it's going to be 100 raised to the second power, which is 10,000.
There are always 2 balls at a time. Supposed to take out one and then put it on, going on the next ball and take out one and then put it on.
No, that's not what I told you.
So did it say
Let's
you
just
pick
read
2 each time? I
Let
pick
us
a
read the
ball at
question.
random from each ball.
Let us read the
But
question
at the
again.
same time,
Let us read the question. Let us read the question again and tell me if you see your answer in it. It says, suppose I have 2 balls, each containing 100 balls, numbered 1 through 100. I pick a ball at random from each bowl. From each bowl. And
So that
look
means
at the number on them.
it never says simultaneously.
yeah, that would no, but that would have worked better. That would have been more clear. But you see where it's I pick a ball at random from each bowl. Yeah, it means you're taking up 2 at one time. But simultaneous would have worked much better.
But I don't have to. If I say Simon, at the same.
What was the answer?
Murder.
10,000.
Oh,
No,
it's
hold on.
10,000.
Hold on. Oh, wait, see a while ago, he wear glasses. I also saw a while ago. No, you see, you have to come in there. It's all right. All right, let me just say no. So Mike, you know, have a calculator. Asia come to class and eat dinner every night. No, you talk about me with my glasses. It's all right. It's one love. One love.
Sir, so the 10,000 correct then?
10,000 is correct, but yeah. But
yeah.
Asia, I'm coming back to you though, Asia, because you're saying, or was it Dan? One of you were saying that no, or Benico. One of the ladies was saying, but it never said at the same time. But let me read the question.
Apart, sir.
No, but Asia said first.
Asia said that.
Asia said, you know, Asia said, I pick a ball at random from each bowl. So I don't have to use the word simultaneously. Paz was saying that if I use the word simultaneously, it would have sound a little better-ish. But I don't have to use the word simultaneously. I can simply say I pick a ball at random from each bowl. So I have 2 balls side by side. I'm going to pick a ball at random from each ball. I'm going to look on the ball then. I'm going to look on the ball. It's order of importance here. It's order of importance here. Yes or no?
No.
Was order important up here, so in order to get the sample space, the sample size?
No.
Hello, read this. What does it say?
Yes, sir.
Yes, sir.
Important.
Order is important.
Like, I was thinking the first one that we had done, and then we did it a second time, and we did it in order. So that's why I had said.
Oh, no, man. When I say order, no. No, man, it's the same, it's the same thing that we got to know.
Yeah, that's what I'm saying.
Right, right.
But
It's
we
the same
didn't do
thing.
it in order the first. Okay.
But what I'm saying to you is order is important. So if when Asia, Miss World, when I go into one bowl with one hand and the other bowl with the other hand, and I pick up, say, 1 and 15. And I say, oh, I have 1 and 15, and I put it back. And I pick up 1 and 15 again. Wouldn't it be the same thing?
Yeah.
Oh, yeah, yeah, yeah.
It would be the same thing. But if I pick up 15 and 1, would that be a different thing?
Yes, sir.
It would be a different thing. So therefore, I have 2 bowls. With 100 balls each in it. That means my base is going to be 100 and my power is going to be 2. So therefore, 100 raised to the second power is going to be 10,000. So I'm going to have 10,000 different combinations. No, you and I are not going to sit down and write on a different combination. So we can have 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6.
Yeah, it's a lot.
1, you get the point I'm making?
Yes, sir.
Until I get 1 and 100, then I can move
To
2,
2.
1, 2, 2, 2, 3. You see the point I'm making?
Yeah. So you have to repeat the experiment all the time.
So let us talk it through. If I go 1, 1, 1, 2, 1, 3 until I reach 1 to 100, how many times, how many tries that? Come on, guys, you're not thinking. If I say
100 times.
it will be 100 times. All right? And then now, when I go 2, 1, 2, 2, 2, 3, how many times that will be to 100?
200.
It will be 200 in total, don't?
Yeah.
Because that will be 100 times again. And if I go 3, it will be how many times again?
300.
In total, don't?
In total.
And 4 would be 400.
400 in total.
Every time I go from 4, 1, 4, 2, 4, 3, right down to 100, it's going to be 100. So we're going to have 100 times. And 100 times 100 is going to give me 10,000. So I'm going to have it 10,000 times. Can anybody see through that?
Yes, sir.
All right. Asia, does that make sense to you?
Yes, sir. Question, sir. So using that reasoning with the coin one, would it work as well instead of drawing the diagram? Because this is a bigger number, so I get why I didn't draw it. But for the top one.
And that's something like you. Because meaning I go sit down, it me love teaching that much, I go sit down and draw something for 10,000 times. No, sir, I mean, I do that. So that's why I do a simpler question. So I can show you the significance of it, so that when we get a question that we can't draw out, we can just go ahead and calculate it. You follow me, love?
So then, sir, could we use the same reasoning with the coin and get the 8 and the 3? And get the 8 from the 3?
Which coin?
The example you drew at the top.
The example we did before, but that's exactly what we did. We know the possibilities were only head or tail. So that's why we have it as 2. And how many times did we do the experiment? 3 times. So that's why we have 2 to the third.
Oh.
That's why we have 2 to the third to get 8. And then in this case, we have 2 bowls, each containing 100. So 100 is my base. It's all about the base, right? It's all about the base. So each bowl has 100. But how many balls am I picking at a time? 2 balls. So that's why it's going to be 100 raised to the second power. But if you look at it the way that I asked you to look at it just now, based on the calculation, you'll recognize that it does make sense. How and why? Because just imagine this with me. Just imagine this with me. 1. All right. So when I say 1, 1, it means that I'm using my left hand and then my right hand. So when I say 1, 1, 1, 2, it means the first number I call is going to be my left hand, the second number I call is going to be my right hand. So I have the two balls labeled 1 to 100. I use my left hand, pick up 1. It so happens that it's a 1. My right hand is a 1. So I can write it in order. Of course, I may not pick up 1, 1. I may pick up 115. I may pick up 25, 10. You see what I'm saying? But to see the significance of it. Why am I saying this without even jotting something down? Forget that I can write. All right. I could have 1, 1. I could have 1, 2. I could have 1, 3, all the way down to 1, 100. You follow me?
Yes, sir.
Then I could select 2, 1, 2, 2, 2, 3, all the way down until I reach 2, 100. Then I could select 3, 1, 3, 2, 3, 3, all the way down to 3, 100. In total, how many combinations I have right there? So how many times would I have this? 100 times. Very good. How many times would I have it right here? So
200 times.
100 times. And how many times here again?
100.
100 times. All right. And then now, when I go 1, 1, 1, 2, bam, 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 I'm going to have 101. Because remember now, say all of this, you recognize that it's a 1, 1, 1, and down there's a 1. Then we're going to have 100,
2.
103, 104.
Very good. Dot, 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 until we reach 100, 100. Talk truth.
Yes, sir.
How much time I have it? How much time would I do this out here, sir? Say 100 again.
100.
How much time would I do it come down here, sir?
100.
Very good.
100. Wait.
And how many time would I do it come right here, sir, too?
100.
How many time would it come right here, sir?
100 again.
And down here, sir, 100 again.
100,
It's what is happening. So when I look at it, I am at 100, 100, 100. So it's 100 times 100. Because if I look at it mathematically, this is going to be 100 times, and down here is going to be 100 times. So in order to find the total number of something in here, so it must be 100 times 100. Talk truth.
Yes, sir.
Everybody see that now?
Yes, sir.
So I'll end up with a square right here. So because I'm going to have 100 go left and 100 go right. But I want you to be able now to see things in a manner where it makes a lot of sense, because there are other questions I can give you. There are other questions I'm going to give you. Not now because time done. But there are other questions I'm going to give you. Let me ask you one last question. Which set of outcomes defines the event that the two balls add up to 200? Which set of outcomes define the event that the two balls add up to give it 200? Pretty much me ask you a question.
The two balls them.
Think about it. You could be right, or you could also be wrong. Hear what I'm asking you. How many times, how many outcomes will I have where the two balls where the two, when I pick with one hand, I pick with the other hand, I'm going to get a sum of 200. How many times that will happen?
Oh, 100 times.
200? Is it 200 times?
100 times because you have to pick 2 balls
All right.
100 times.
So look at this. Look at what I'm saying here. So in this case, what is the sum right here? So the first one, the sum is how much?
100.
100.
No man, say 2.
Oh, 2.
Where?
Oh,
Oh,
And
2.
what's the sum right here? So say 3.
oh, you mean, oh, and then 4.
And then 4. And the sum right here is going to be 101, don't?
Yeah,
You follow me? And the sum
yes.
right here is going to also be 101, don't? And this is going to be 102, don't? And 103. So I'm saying, how many times will I do this experiment? How many outcomes will I get when I out of the two bars them and I'm going to get 200?
There, I'm not follow.
All right. You know what an outcome is, right?
Yeah.
We do an experiment, the result is going to be an outcome. Talk truth.
Mm-hmm.
Good. We already agreed that in this experiment, we're going to have 100 times 100, we're going to have 10,000 outcomes. You see that?
Yes, sir.
Good. I'm asking you, out of these 10,000 outcomes, how many outcomes will I have where the sum of the balls will give me 200? Let me ask the question another way. How many outcomes will I have where the sums of the ball will be equals to 2?
Would equal to 2.
Mm-hmm. One.
Sir, 1?
One. See, track of yourself.
2.
1.
Yeah, 1 and 1 give you 2.
Let me ask you another question. How many outcomes will I have where the sums of the ball will give me 3?
1 and 2.
How many
Oh.
outcomes?
2.
Right, it will be 2 outcomes.
Yeah.
This one
Because
and this
one is
one.
yeah.
How many outcomes will I have where the sum of the balls will be equals to 4?
1, 2, 3.
1,
1, 2,
2 and 3.
You follow what I'm saying?
Yeah.
Yeah.
How many outcomes will I have where the sums of the ball equals to 200?
1.
One time,
Yeah,
which is which
100,
one?
the last one.
Duh.
100.
Okay.
Jesus. Yes, man.
Sorry, you have to see with you.
No, man, no worry about it, man. Say it again.
Selection.
Sir, me never did a follow you. That's why.
No, man, but and that's fine. But when you can say,
No.
Benika is saying something?
No signal here. I was saying, I thought you said 100 and not 200 because I was trying to add up the 50 and the 50, 75, 25. But I never know it was 200, you said.
okay, all right. No, man, yeah, it's 200. So that's what I'm asking. So when you look at it now, the question is really saying, which set of outcomes defines an event that the two balls add up to 200? There's only one event that will give me the balls adding up to 200. And it's when I get 100, 100. There's only one dege event that the balls get add up to 2. Let me ask you, I know you have a class, but this is the last question. How many events will I have where the sums of the ball equals 1?
None.
0.
None.
None, 0.
0. You know why? Because the balls them number from 1 to
1
100,
to
so I have no
100.
0. And I have to pick 2 balls at a time. So that is going to be none. So I will never have anything like that. So this is where I want you to go. I mean, I am going to, I don't have anything type up on this. So I'm going to use this note something. I'll send you this write up notes, and then I'm gonna, send off something for you so at least you can have it to reflect on. But yeah, this is what probability is. This is you creating your chances, and you may wonder how this is important. The truth of the matter is we can do probabilities to check to see when will the garbage truck come to collect your garbage in a particular area. You can use the probability to see when it is likely to have rainfall. Anybody recognize that the time is hot?
Yes, sir.
Yes, sir, very.
It cold right now still.
No.
Michael,
Good
Go
for
away.
you. Good for you,
Michael.
Michael.
Go away. Hey, pause. Let me tell you something, man. Sunday, one piece of heat box me. It's when they turn on the fan, the heat that's circulating. Oh, some father. No man, the time hot.
Can you imagine summer?
No.
In the sun, I couldn't see for drive. The sun turned up.
Listen to me. Venica, let me tell you something. Has just said a while ago, say, and I'm speaking to you on this because you guys are environmental study students. Has said to me, say, and summer don't come to remember last summer how I was about to say expensive, because last summer every day I had to use AC. And guess what? To the point where JPS came out to say last summer was their most profitable time of the year because of how many people have used AC. No man, JPS actually came out and said that last summer, the months of August, July and August, was most profitable for them because more people use more electricity because people are using AC. The time it's very hot, and already I'm seeing that trend happening for this year again. It's miserable.
Sir, hurricane season not go normal this year. All the water temperature them hot already.
Sir, I am worried. Iceland already again had another volcano. Danikas, Jeez,
the poor dog.
One of me when I grew up on him foot.
Jeez, I'm father. Oh, you see so? Me need somebody to work with JSPCA so them can lock you up. Oh goodness. The poor dog don't do you nothing, you clothe him. Anyhow, big up on yourself. Have a good one here.
All right, sir. Nice.
Take care.
All right,
Yeah,
sir.
man.